derivative, that's what I do. So u of 0 is 2, means 1 minus 0 plus c equals 2, or c equals 1. So therefore u of x is unique, is not a family of functions, and it's this. Good, next question.
Number 3.
Number 3. Good. So what do we do with number 3? Yes. The integral from 1 to 4 from f of x dx, where the integral, the function is given as a piecewise, it's a piecewise defined function, e to the x minus 1 over x squared, x less than 2, and negative 2x cubed for x greater than or equal to 2. Very good. So, how do we write it?
Integral 1 to 2.
Yes. So, no, we have to start with the integral from 1 to 4 from f of x dx, and we have to write this. But that's the starting point. And yes, then the limits of integration will be from 1 to 2 and from 2 to 4. Do we all see that? Why it's going to be between 1 and 2 and 2 to 4? Yes? Okay, 1 to 2 from which function dx, and 2 to 4 from which function dx?
1 to 2 is the first one.
Yes, e to the x minus 1 over x squared, and negative 2x cubed. Are these functions continuous on these intervals? Because otherwise, I'll say, sorry, I can't. Yes, they are. The first function is defined everywhere except at 0, but 0 is not in the interval. The other one is a polynomial defined everywhere, no problems. So this is e to the x plus 1 over x from 1 to 2. Because e to the x prime is e to the x, and as we know, a long time ago, I begged you to remember that 1 over x prime is right. It saved us a lot of time remembering that. Okay, and then negative 2x to the 4th over 4 from 2 to 4. Now you see why I insisted on that. It saves us a lot of time. Okay, we plug in 2, and we get e squared plus 1/2 minus e minus 1. Then minus 2, leave it at, negative 1/2, sorry. Negative 1/2, leave it alone, and 4 to the 4th minus 2 to the 4th, which is 16. So e squared minus e, and this is minus 1/2, and then minus, how much is 4 to the 4th? 16 times 16. 256, right? Okay. 256 divided by 2 is,
Wait,
no.
minus 16 is 240. Would you want to keep it open?
I wanted to do two. It doesn't matter. You're right. It's the same thing. So let's keep it as okay. 256 minus 16. That's fine too. That's perfect. E squared minus E minus 1/2. And this is, yes, indeed 240. 240 divided by 2 is minus 120. So this is still E squared minus E. 240, so negative 241 over 2. Good. Next question.
For 4a, how would you write that it's equal to 0? If you just
I will simply say that there is no width. There is no width of the interval. So the area under the graph of a function is width times height, but there is no width. There is no interval between 10 and 10. Is that clear? So yes, the answer is 0. Good. Next question.
4b.
4b. Very good. Let's write that. This is the integral from 0 to 4 from 1 over the square root of 1 minus x squared dx. Very good. What do you think about this?
arctan sign,
Arc sine.
arc sign.
Okay. So, we forgot to do something very important.
I see it's continuous.
It's not continuous. It's not continuous. It's not defined at 1 and it's not defined at other values as well in this interval. FTC part 2, not applicable. This is an improper integral. Calc 2. Good?
Why is it?
Because if you plug in 1, you get 1 over 0. And 1 is in the interval, as an example.
Things are 4?
Yeah, the function is not continuous.
Then you do 1 minus 0.
So first of all, you cannot even plug in 2. Even if you plug in 2, you're in trouble because it's 1 minus 4, which is negative 3, and the square of negative 3 is not a real number. So at least if you notice that 1 doesn't work because it's 0 in the denominator, but there are many other values for which the function doesn't exist, not just that 1.
So it's not continuous because of that.
It's not even defined.
It's not even defined.
Yes, in certain parts of 0 to 4 is not even defined. So the fundamental theorem of calculus requires that the function not just exists, but not that is for particular values that exist, but it has to be continuous on the entire interval. So exist and continuous, yes. Yeah. So be defined and be continuous.
The part C would be different because there's no interval for it.
So this is an indefinite integral, so the answer is going to be a function. So there is no limits of integration, this function. So the result is not going to be a number. And we are not using fundamental theorem of calculus part 2 for this one. How do we continue?
Substitution.
Yes. Awesome. Which one? How?
2r pain.
Yes, indeed. Let's do just that. Perfect. So let's say let y be arc tangent x, as long as dy is in the problem or easy to make up. Yes, 1 over 1 plus x squared dx. Excellent. So all this is du. So then the entire integral becomes what? Yes, the integral from u to the fifth, yes, y. dy, very good, which is y to the sixth over 6 plus a constant c, and I have to go back and rewrite 1 over 6 arctangent x to the 6th power plus a constant c. Very good.
So then it goes from to the fifth power to the sixth to the end.
But remember how we go back. Which function prime is y to the fifth? We increase the power by 1 and we divide by that number, right? Because now when I differentiate this, I get that.
Right, not just
When I differentiate this, I get that.
you 1 over 6.
Right.
Okay.
Good, next question.
6.
Okay, let's take a look. 6. Yes, the displacement, very good. So we are given v of t, which is 3t minus 12, and the interval is 0 to 10. So we're asked to find two things. First, the displacement, which is always s of 10 minus s of 0. For the given interval, of course. Which must be the integral from 0 to 10 from v of t dt. At least this one is not a quadratic function. So we get 3t squared over 2 minus 12t from 0 to 10. And luckily we only have to plug in 10. So 3 times 100 over 2, which is 50, plus minus 120. So 150 minus 120 is 30. So the particle moves 30 in the positive direction. Now, for part 2, we are asked to find the total distance, which will be the same thing, but from the absolute value of v of t dt, which is a different story. So I have to work on this first. So this is 3t minus 12 in absolute value, and we know any absolute value has two options. And what are the options? So what do I write?
So 3t minus 12. and
Yes,
negative 3t.
but the if is very important. If what?
X is greater than or equal to the same thing. 3t minus 12.
If 3t minus 12 is positive, not x, not t. So let's go back to the formula one more time. This is very important. Okay, any expression, in absolute value is the expression if the expression is positive or 0, or negative the expression if the expression is less than 0. So remember what I was saying, please remember this. See, I have 5 identical situations. 1, 2, 3, 4. I have identical, but I already distributed a -1. Now I have to solve this, which says greater than or equal to 4. I don't have to solve this ever. It's the other side. Whatever the first one is, the opposite will be the second one. If the first one is greater to 4, the other one is less than 4. If the first one is less than or equal to -3, the other one is greater than -3. So then we have two situations. What are they? So then the total distance, the integral from 0 to 10 from the absolute value of v of t dt equals, indeed, the integral from 0 to 4 and from 4 to 10. 0 to 4 from what? Careful.
Oh, other one.
Yes. -3t plus 12 dt and 3t minus 12 dt. This will give us the total distance covered by the particle no matter which direction the particle is going into. Exactly what we did with the particle in chapter 3, but we didn't know integrals then. Same thing. We didn't know how to integrate velocity to get the distance. So we did it a different way. Okay, so let's find the total distance then. -3t squared over 2 plus 12t from 0 to 4 plus 3t squared over 2 minus 12t from 4 to 10. Luckily for the first one, I only have to put in 4. So -3, 4 squared is 16 divided by 2 is 8 plus 48. And I don't have to plug in 0. Now when I plug in 10, so it's 100 divided by 2, which is 50. 50 times 3 is 150, minus 120. But minus, careful when I plug in 4. 16 divided by 2, 8 times 3, 24, and minus 48. So -24 plus 48 plus 30, and this is -24 plus 24. I got 78. So the particle, and we had the measurement unit was, yes, so it was meters. So then in this case, the distance is 78 meters, and I have to put the measurement unit.
So displacement would be the meters per second.
The displacement is basically the distance covered from the beginning to the last point, which can be this, or it can be this, or it can be this.
Okay. That will always be an absolute number.
This one is always a positive, because we're integrating a positive function. Yes. Very good. Next question. Can you think of anything else that may not be here and you want to go back to?
Can we do another displacement?
Yes.
Yeah.
Yes. So the displacement is in 5.4, I believe, if I'm not mistaken. 5.4. Yes, page 405. Or we can look at the end of the review, see what they have in there. Because we looked at the linear function, we looked at the quadratic function we have there, we looked at both. Okay, displacement. Yeah, Yeah, they don't consider it a big deal, so it's nothing in their review. Do you have a problem, maybe from WebAssign? Greg, did you find this in WebAssign or not yet? The displacement.
What section are you looking
5.4. The indefinite integrals and the net change theorem. That's the net change. Absolute distance, total distance. Okay, I found one. Unless you did. Did you?
for? No, let's see.
Okay, so we have the velocity, v of t, t squared minus t minus 6, and we are given the time period between 1 and 4. So we have a velocity, we're asked to find the displacement between 1 and 4, and also we are asked to find the total distance between 1 and 4. So the displacement will be, yes, displacement is s of 4 minus s of 1, which is the integral from 1 to 4 from t squared minus t minus 6 dt, which is not a problem. T to the third over 3 minus t squared over 2 minus 6t from 1 to 4. So we plug in 4. 64 over 3 minus 16 over 2 minus 24. And minus when I plug in 1, 1/3, minus 1/2, and minus 6. So I calculate this, it's 64 divided by 3 minus 32 minus 1/3 plus 1/2 and plus 6. Okay, can I simplify anything? Yeah, a little bit. 63 divided by 3 is 21 minus 32 plus 6, but plus 1/2. So 21 plus 6 is 27, right? So that's minus 5 plus 1/2. So I get negative 9 divided by 2. So what does that mean? It means that the particle moved 4.5 meters towards the left. Meters. So now we're asked to find the total distance. But the total distance is a totally different story. So t squared minus t minus 6 in absolute value dt. I can't start just yet. What do I have to do first?
Evaluate the absolute value.
Yes, yes, show the two options for the absolute value. T squared minus t minus 6. And remember the definition of the absolute value, right? T squared minus t minus 6 when t squared minus t minus 6 is greater than or equal to 0. Or negative t squared plus t plus 6 when t squared minus t minus 6 is less than 0. I'm trying to make a point. Don't delete it like that. Don't erase it like, don't cross it out. But I will never solve the second inequality. Because whatever it's not in the solutions of the first will be in the solutions of the second. Okay. So now, how do I solve this inequality? Yes. There is no other way. I have to factor. So this is t minus 3 and t plus 2. And then I will use the table or any other method you prefer, of course, to study the sign of t minus 3 and t plus 2. Which values will you put in the table at the top? Yes, negative 2 and 3. They have to be in ascending order. Since both are linear functions with a positive slope, they have to come from negative and go positive. So when we multiply or divide, it doesn't matter. Two negatives, we get positive, in the middle negative, and on the right hand side positive. So now I have the answer for this. And I have the answer for this. Inequality. What do I write? So let's rewrite it again. So t squared minus t minus 6 in absolute value is t squared minus t minus 6 when or if what?
Write it, but like the union.
Yes, negative infinity, negative 2, union 3 to infinity, very good. Or negative t squared plus t plus 6 for t where? Yes, with parentheses. Because I used brackets in the first one, I can no longer use brackets in the second. Okay, after all this work, only now I'm ready to find the total distance, which is the integral between 1 and 4 from the absolute value, which turns out to be finally a sum of two integrals. Sum of two integrals, and the integrals are, careful, from, careful, from 1 to, yes, and from 3 to 4. And of course dt and dt, and we have to be very careful now to choose the correct function. From 1 to 3, which function do I choose, top or bottom? Yes. Yes, negative t squared plus t plus 6 and t squared minus t minus 6. Okay, so negative t cubed over 3 plus t squared over 2 plus 6t from 1 to 3 plus t cubed over 3 minus t squared over 2 minus 6t from 3 to 4. I think I mentioned that I had one professor teaching a statistical inference course about, it was a stats 650, and he would stumble. I think, I hate to say that, but I think he had some drinking problem. Okay. So he couldn't remember what to do. And he would say, from here is messy, you do it. From here is messy, you do it, but I'm not lazy to do it. So that, I remember. I think he retired finally. It was the worst class ever, my entire life. Did I mention him to you? No? He would write on the board and never erase the board. And at some point in time, he wanted to write something, and he would do this, and write in the middle circle, a little circle. He would erase it with his elbow, and he would write this. And then sometimes, I don't want to smash it, but anyway, so sometimes he had an eraser in his hand, and from far away, he would slam it like that, it would fall on the floor, of course, and never pick it up, I guess. That's why he never erased the board. It was the worst class I had ever, worst professor I've ever had, ever.
I had a geography teacher like that. He got annoyed with the pencil sharpener and threw it out the window, and the cord was still plugged in, so it was just hanging out the window.
So, if you want to finish it up, we'll finish it up now. If you want to finish it up later, I can. So let's plug in. Okay, so 27 divided by 3, negative 9. So plus 9/2 plus 18 and minus negative 1/3 plus 1/2 plus 6 plus 64 divided by 3 minus 16 divided by 2 and minus 24 minus 27 over 3, so 9 again, minus 9/2 and minus 18. Okay, let's see what we do with this. I have a 9, I already see a 9 plus 9/2 plus 1/3 minus 1/2 and minus 6. and then plus 64 thirds, and this is negative 32, minus, this is negative 9, so plus 9, and plus 9 halves. Let's see if I can do anything now. 9 plus 9, 18. 18 minus 6 is 12. Negative 32 minus 12 is negative 20. Now, you know, I already put these. You know we are determining an integral from a positive function. What should the answer be for sure? All right, so whatever I get, I hope, you know, we hope we didn't make an error, but it has to be a positive number. So I took care of these, I mean this, and this, and this. 9 halves plus 9 halves is 18 halves, which is positive 9, so that's done. 64 over 3 plus 1 is 65 over 3, so these are done. And the negative 1/2 now. I think I took care of all of them. So negative 11 plus 65 over 3 and minus 1/2. The least common denominator is 6. This needs a 6, and this needs a 3. I'm in trouble. Negative 66 plus 65 minus 3. So go back to the drawing board. We didn't make any error.
I think it's the over 2 one, since you got 9.
Did I forget something there?
You got 9 plus 9 minus 1.
So everything is fine here. I'm checking my calculations. Okay, that's fine. Now here, so this was a 27 over 3. That's 9, right? That's 9 halves. Now if I made an error, I go back to the beginning. So then minus, it is negative 1/3 and plus 1/2 and plus 6. That's okay. Now I plug in 4. I have 64 over 3, right? 16 divided by 2. This is negative 24. Then I plug in 27 divided by 3. And then minus 9 halves and minus 18. I'm okay so far, right? So this with this will be 9. I copy this. I copy positive, negative, and negative. Yes. I copy this. This is negative 32, correct? Then I have 9 minus 18, which is negative 9 with minus in front is positive. And then negative 9 halves and 9 halves with minus. Where did you see a mistake here so far? Maybe you see something I don't.
So it says 9 halves plus 9 halves minus 1/2. We wrote it as negative 1/2 instead of.
So, no. So here's what I did. Let me check. So 18.
Oh no, I mean for like the next part. So you're gonna add like the 9 halves plus 9 halves minus.
Yeah, 9 halves plus 9 halves is 18 halves, which is 9.
And then minus 1, well, 1/2. So it would be plus 17 over 2 instead of negative 1 over 2, right there.
Well, I didn't calculate. I just copied it.
Oh.
So,
That's 61,
so then what did I do? So 9. So I had 9 plus 9, 18. 18 minus 6 is 12. Negative 32 plus 12 is negative 20. Correct? So then these are done. Then I have 9 halves plus 9 halves, which is 18 halves divided by 2, which is 9. Correct? This one. Then I have 64 over 3 plus 1 over 3, which is 65 over 3. So this is done. And then minus 1/2. I just copied it. So this is negative 11. This is 65 over 3, and this is minus 1/2. Is that okay? But I'm getting a negative number, and that's impossible.
Yeah, I got 61 over 6.
I got 61 over 6 also.
I'm not sure like where it went wrong. Something in that last step.
Yeah.
Is it 6 times 4 still 24? Minus 27 over 3, still 9. 9 halves. And negative 18. Maybe I should just redo this calculation one more time, just from here, and not look at what I just did. Okay. So negative 9 plus 18, right, is 9. And then plus 9 halves. And then plus 1/3, and minus 1/2, and minus 6, correct so far? So then plus 64 over 3. And this is it negative 32? And this 9 minus 18 is negative 9. But with minus in front will be positive 9. And this one will be positive 9 halves. So 9 plus 9 is 18. 18 minus 6 is 12. Negative 32 plus 12 is negative 20. 9 over 2 plus 9 over 2 is 18 over 2, which is 9, correct? So then this and this is plus 9. Then 64 over 3 plus 1 over 3 is 65 over 3. This and this. And then I have a minus 1/2. I'm getting back to negative 11 plus 65 over 3 minus 1/2. And I get the same thing. So I have to go back to the beginning. So
we forgot to do 65 times 2.
I see. That's what I did. Okay. Got it. Okay. Good. So times 2. Okay. Now this is fine. And the very last step. My grandma used to say, try not to sink at the on the shore. So I'm sinking at the shore right now. I got there. Okay. So negative 66 plus, indeed, plus 2 times 65 and minus 3. So indeed, 61 divided by 6. Okay. Thank you for your help. So now this is possible. So 61 divided by 6, that's okay. So the 6 is the least common denominator. I have 6 here, but I didn't multiply by 2 here, and that's 3 is okay. And I multiplied, but I didn't put the correct number up there. Sorry, my apologies. So indeed 61 over 6. But at least we understand that we knew what to expect. So this was the area